All right, so we are going to finish up our material this week looking at section 1.2. And this is going to be quite a bit of stuff on the graphing calculator. So we'll need to make sure we have those in a minute. And just kind of doing a little bit more with zooming in and out. And we're going to start with a word problem that's going to help us to learn some of those things on the calculator. So when we are solving a problem, and it's not just a math problem, pretty much any kind of problem we're trying to solve, these are just some general suggestions about how to go about it. So the first thing we have to do is make sure you understand what is it that they are telling you in the problem, and what is it that they want you to figure out. All right, so kind of organize what's given to us and what it is that we need to find. After we figure out what it is that we know and what it is that we don't know, then we have to come up with some kind of plan to solve the problem. Thank you. So when you have a word problem, okay, and they give you a lot of information in like sentence form, what's something that can help make all that information a lot easier to interpret? If they give you a lot of information in sentence form and somebody's not really an English person reading all that, what's another way to represent all that information? Yeah? Okay, so we might come up with, we might pick out some variables. And what would you use variables in? An equation, yeah. So that's one approach. We might make an equation. Now, sometimes the equation you make is something that is well known. If you're doing a problem about the area of a circle, there's already an equation that's known for that. Okay, so you might be able to just use an equation that's established. Or it might be a very specialized problem you're doing that the equation you need to make only applies to that problem. So it's not like a formula you can go look up in a book and say, okay, there's my formula. So you might have to figure out your own formula, or you might have one you can look up. What's another approach that we do a lot to make things kind of easier to visualize in math? If we just have lots of sentences written out. Yep.
Like pictures and graphs?
Yeah, we might draw a picture, right? So if we say, you got a building 200 feet tall, you're standing 50 feet away, you're looking up at an angle of 30 degrees, or a shadow, or you get all this different information. It might be a lot easier to put that information in a picture rather than having all those sentences. So pictures are good. A list, sometimes a list is helpful. It depends. So let's say I said to you, I want you to take the letters A, B, and C and tell me all the different ways that you can arrange those letters. Well, you've got ABC, ACB, BCA, BAC, CAB, CBA. So there's 6 different ways you can do it. It's not bad to list them all. Didn't take that long. But what could be a downside of trying to do a list? What could happen that wouldn't make a list very practical?
You have like more than 3 variables?
Yeah, if you had a lot of things, right? If I said to you, I want you to tell me the number of ways you can use each letter in the entire alphabet and how many different orderings you can have of all those letters. Well, I mean, that's just not practical to come up with a list. And the question really wasn't asking you to come up with a list. It was asking you how many ways can you arrange all the letters. A list might help in a small case, but in bigger cases, we need a better way than a list. Okay? And then we already talked about an equation. Okay, once you come up with either your own equation or you look up the equation, if it's something about like area or volume or perimeter, like something you can just look up in a book, then we have to look at how we solve it. Okay, for linear equations, kind of equations you start out with in Algebra 1, we just have to isolate the variable. Okay. When we get into more complicated equations, like a quadratic, we still have to isolate the variable, but we might have to use something a little more complicated. You might need factoring. You might need quadratic formula. Completing the square, that's another way. Some people don't remember that one as well. But we have to figure out how we're going to actually solve the equation. All right? And that's where the third part comes in. Right? So maybe you've read the problem, you figured out what it is they're giving you and what you need to find. Maybe you drew a picture and an equation. Maybe they kind of go together and helped you figure it out. Now you have to figure out what method are you going to use to actually get the answer. Okay? Actually go ahead now and solve the equation. Okay? How are you going to do that? So we're going to look at a word problem. We're going to come up with an equation. We're going to solve it algebraically, but then we're going to take that same equation and I'm going to show you how to solve it graphically, okay, on the calculator. Any questions on those steps? Okay. So let's take a look at this problem, and then we'll figure out how to come up with an equation. So this is about I've kind of just put the essential information you need, and I really shortened the word problem. So there's a rental car company that rents cars. They charge $15 to rent the car. That's a fixed fee. And then it's a charge of 20 cents for every mile you drive the car. And I want to basically come up with an equation that is going to allow me to figure out the price you pay to rent the car in that scenario. Okay, so first thing we have to decide is how we're going to make our equation. Okay, we're not drawing a picture. That picture wouldn't really help here. And they tell you the approach they want you to do. Make an equation. What, we kind of said this earlier. What is something that a lot of equations have in them? Variables, yeah. And this equation is going to have that. First thing we have to do is decide how many variables we're going to need. How many variables do you think this equation will have? One? What do you think that variable would be?
X.
Okay, so we have to pick a name for it, and what would that variable represent?
Per mile. Like how many miles you drive.
How many miles you drive, absolutely. We definitely need a variable that represents how many miles you drive. But how many miles you drive is going to affect something else that's a variable. Yep.
The total cost.
The total cost is a variable, right? You can't just walk in and say, what's the price for the car? They'd say, well, when you come back, we'll tell you after you tell me how many miles you've driven, right? So the cost is a variable as well. Generally, the names that we use are X and Y. And when you use X and Y have a very specific meaning. Okay? And we talk about it more in section 1.3. But X is called the independent variable. And does anybody remember using similar terminology what the Y is called? That's the dependent. So the independent variable is the one you are in control of. The dependent variable is the one that you don't directly control. Okay? You can control how many miles you drive the car. Right? That's up to you. You can't really control the cost because they have a set fee of 20 cents per mile, and the cost is just going to be what it is after you drive the car. Right? So the way, if you ever have trouble figuring out which one is independent, which one is dependent, I come up with a sentence in my head and I read it two different ways. I say, does the cost to drive the car depend on how many miles you drive? Yeah. So does the cost depend on how many miles you drive? Or does the miles you drive depend on the cost? That's the first way, right? The cost depends on how many miles you drive. So cost is dependent on mileage. That's why cost is the dependent. Okay, a lot of times money is usually the dependent. If you work at a job and you're paid by the hour, your pay depends on how many hours you work. Okay, your paycheck is dependent on the number of hours you were at your job. Right, so money a lot of times is the dependent. Okay, so we're going to come up with an equation. And it's basically going to be cost equals, and anyone think they could give me a formula that would represent the cost as a function of how many miles we drive the car? And make sure you use X for the variable. Luke?
Y equals 20 cents times X plus 15.
Yeah. So we have to put that variable next to the 20 cents because that represents a reoccurring cost. It's multiplied by the number of miles you drive. And plus 15, that just represents the one-time fee of $15 to make the reservation. Okay, so there's your equation. Any questions on that? So a lot of times what we do is we call that equation the model, right? It's modeling what's happening in this problem. So let's use that equation, okay, let's use that model to figure out the cost to rent the car if we drive 50 miles. Okay. How would I figure out the cost to rent the car if we drive 50 miles? Yeah, Christian?
You plug the 50 miles into the X.
Right, you're going to take 50 miles, and we're going to fill that in for X. So we have Y equals 0.20, 20 cents, times 50, plus 15. 0.2, that's 2/10. What does that reduce to as a fraction, 2/10? Yeah?
1/5.
That's 1/5, yeah. So right here, that's 1/5 of 50. What's 1/5 of 50? 10. Yeah, basically 1/5 means divide by 5. Right? So if you take 50 and divide by 5, you get 10. So it's $10 there, plus 15. If you drive the car 50 miles, that's a cost of $25. Any questions on that first one? Okay, so now let's do the same thing. 100 miles. Okay. Now, can I just quickly say, all right, 100 miles, that's double the miles. It's just going to be double the cost, $50 to drive 100 miles. No, why doesn't that work? It sounds like it should work. Double the miles, double the cost.
Because you're still only paying $15 to rent the car.
Right, you're only paying the $15 fee one time. If you double the 25, you're doubling the $15 fee as well, and you don't want to do that. Okay, so we're going to do Y equals. We're still going to fill in 100 for X. And then add 15. What's 0.2 times 100? 20. Just move your decimal 2 places to the right because you're multiplying by a power of 10. So 20, and then 20 plus 15? 35. Yep. So a lot of people, well, several people, right away jumped in and said, no, if you double the miles, you don't double the cost, right? And that's important to see because sometimes when there's a problem that's a little more complicated, you might try to use that kind of reasoning. like something simple. Okay, that number's double, so maybe that number's double. But that kind of reasoning doesn't always work. Right? It's more obvious that it doesn't work in this situation, but it might not always be as obvious. Okay, any question on that? All right. So that equation that we came up with, sometimes we call that like the algebraic model, or you can also call it the algebraic representation of the problem. So if somebody were to walk in right now, right, and they look at the board and they saw that, they have no idea that that's about renting a car, and you pay 20 cents per mile and $15 up front. All that information has been kind of represented in that equation. It's kind of hidden in it. Okay, but unless you have the context for it, you don't know what it really means. So when they ask you in the homework to come up with an algebraic representation of a problem, it basically means to come up with an equation. Now, is this a well-known equation? Like, is it one that you could reference somewhere in a book for this problem? Yeah.
It's the slope and y-intercept equation, isn't it?
Okay, so yes, it is written in y equals mx plus b, which is slope-intercept form. So let me be a little clearer. Could you look up this formula in any math book and find exactly that formula with those numbers? No, that's not a well-known formula. All right? It's not like writing, a squared plus b squared equals c squared. That's different. That's the Pythagorean theorem. It's a well-known formula. It's more universal. You use it all the time. This is just an equation that's very specific to this problem. That's all it is. Okay? Probably not a formula you'll ever use again. You might use the structure of it, y equals mx plus b, but probably not those exact numbers. All right, so now let's try using that equation again, but we're going to do something a little different. So from our example, it says, suppose Sarah was charged $50 to rent the car. How many miles did she drive? Okay. What's different about this question compared to the other two? Yep.
You have to swap 50 for y instead of x.
Right. When we plug in this time, you're plugging in 50 for y. You are plugging in for the dependent variable. And now you're solving for the miles. Okay, so let's do that. We are going to do it two different ways. Okay, the first way we're going to do it is algebraic. Okay, so we're going to take y equals 0.2x plus 15. Just copy it down so I can see it. And I'm going to take the $50, and I'm going to fill that in for y. 50. And I know I'm writing 0.20 because when you think of money, a lot of times you always write money to two decimal places. But in math, 0.20 is the same as just 0.2. Right? So if you just write 0.2, it's the same thing. Okay. What's my first step to get x by itself, Christian?
Subtract 15.
So we're going to subtract the 15 on both sides. And 50 minus 15 is going to give me 35. All right. And how about somebody else? My last step to get x alone. So my name's Quinn.
Divide by 0.20.
Yep. So divide by the 0.20. So that's gone. And we just said this a minute ago. What fraction is 0.2? 2/10? 1/5. So you're dividing by a fifth. Well, when you divide by a fraction, it's the same as multiplying by the reciprocal. So instead of 35 divided by a fifth, think of it as 35 times what?
5.
5. Yep, so 35 times 5 is our answer. And what is 35 times 5?
175.
175. And that's 175, what's our
Miles.
units? Miles. Okay, so that's an algebraic approach to solve this problem. Okay. Any questions on that? Yes?
If we're dividing by 0.20, where did we get the 5 from to multiply with 35?
So you'd have to know that 0.20 is equal
Okay.
to the fraction 1/5. The only reason I could do that one in my head is because 0.2 is a nice fraction. If I had something like 0.749, well, I mean that is the fraction 749 over 1,000, but I'm not really going to be able to do that as easy in my head because it's not just like times 5. Yeah, so some decimals not as easy to work with. And while we are talking about decimals, let me show you something on the calculator. If you have 0.2, okay, and let's say you want to change that to a fraction and you don't know what it is. If you press math, the first option that comes up is fraction. What that will do if you hit enter is it will take the last number that was on the screen and change it to a fraction if it can. So I don't know if you can see it, but it says 1/5. It just changed it to a fraction. I could do 0.749. Again, it'll change it to a fraction. 749 over 1,000. And it will also reduce it. Okay? So if I did like 0.75, that's 75 hundredths. Right? 0.75 is 75%, 75 out of 100. What does 75 over 100 reduce to? 3/4. So if I type that in, it's not going to give you 75 hundredths. It will reduce it to 3/4. Go. Now, what's going to happen if I type in pi? What did we say about pi yesterday? What kind of number is that?
Irrational.
It's irrational, which means what?
Can't be turned into a fraction.
It cannot be turned into a fraction. So if you try to take a number that's not a fraction and turn it into a fraction, you're just going to get the same answer back. You can't do that one. It also, I don't think it can go too much bigger than 4 digits in the denominator. So I don't know if it'll do fractions that have numbers in the tens or hundreds of thousands in them. But it'll do fractions pretty big. Okay. But that's just a quick thing, not really specifically part of this lesson, but that is how you can change a fraction to a decimal. Okay, so any other questions on how we got 175 miles? All right, so what we want to look at now is how to do it graphically. Okay, so to do this graphically, by hand, graphing is never really a great method because graphing by hand relies on you being able to draw it very accurately, especially if you're going to use that to determine something. And it also relies on you having graph paper. And if the graph is really big numbers, then your graph could go into the thousands. So you're going to scale your graph paper. Like, how are you going to handle that? So graphing is a good approach when we are using the calculator because it can do all of that for you. So let's go back to what we had at this step right there. 50 equals 0.20x plus 15. So essentially what I have there is two different sides of an equation. This is the left side. This is the right side. So instead of thinking about solving it algebraically, I want to think of the left side as a picture, and I want to, I'm going to draw that picture, and I want to think of the right side as a picture, and I'm going to draw that one. And I'm basically going to be looking for where my first picture is equal to my second picture. Now that's kind of a weird way to say what I'm looking for, but anyone think they know what that means? Where my first picture is going to equal the second picture I draw. Yeah?
Like to put two different equations, so one is y equals 50 and then one would be 1 is y equals 0.2x plus 15, and then you see where they intersect in the graphic calculator?
Yes, I'm looking for where they intersect each other. That's what I'm going to look for. So the first thing we have to do before we can find where they intersect is we have to get all that information into the calculator, and we have to set our screen so we can see where they cross. If you can't see where they cross on the screen, you're not going to be able to find the intersection point. Okay. So the first thing we have to do is turn the calculator on. Okay, if you're at a screen that has stuff on it, you can press clear. That'll get you out of that. And then we're going to press y equals. Okay, when you press y equals, that's the button in the upper left. Did we do that yesterday? Okay. There could already be something in there that somebody left. We want to clear it, so there's nothing there. So everyone should be at a screen that has y values going down the left and nothing on the right. I know my screen's kind of dim. It's usually like bright white, but I'll try to fix that. Can everybody see my calculator okay? Yeah. Okay, so we've got that. So it doesn't matter which one of these we type in first, but we're going to put in one of them, and then we're going to put in the other one. I usually put the left one in, then the right one. So we're going to put in 50 for the first one. Now, if you graph y equals 50, does anybody remember what that would look like?
Yeah, it's just a horizontal line.
Yep, it's just a horizontal line at what number?
50.
50. So we got to keep that in mind because our window might not be high enough to see. So we've got horizontal line at 50. And now let's type in this one. And I want to talk about it a little bit, but somebody already kind of mentioned the format that this is in. 0.20x plus 15. What format is that? We call it something. Yep, that's slope-intercept format, which uses y equals mx plus b. And the m is our 0.2x, or 0.2, sorry, 0.2. And does anyone remember what the 0.2 is?
1/5.
So it's 1/5 as a fraction, but when you draw that, it's going to be something special about your graph.
Is that the slope?
It's the slope of your graph. Yep, it's the slope. And the plus 15 is
Your y-intercept.
the y-intercept, which means what?
Where it crosses over the y-axis.
Where it crosses over the y-axis. Yep. So we're drawing two lines. One of them is going to have a positively sloped slant to it, and the other one is a horizontal line. Okay, so now let's press window. We've got to set our window to what really makes sense in this problem. So think about x. What did x represent in the rent-a-car problem?
Price per mile.
So that's not a variable. That's 0.2. So price per mile is a fixed value that never changes.
Oh, how many miles?
But x is something that changes, and it's mileage. It's how many miles you drive the car. Can you drive the car negative 20 miles? Not even if you're in reverse. That doesn't count. It's still positive miles. So what would be the smallest number of miles you could drive the car? 0. You could just choose to make the reservation for $15, and then you decide, if it's not refundable, you don't pick up the car, you don't drive it, 0 miles. Now, x max, what's the most number of miles we could drive the car? Infinite, right? There is no limit. So, maybe let's just put in we'll drive up to 80 miles. Maybe we have to make it higher. Probably. But we'll just put it at 80. Now let's set the y's. What did the y variable represent in this problem?
Total cost.
The total cost. Could you have a total cost of -20? No. Right? What's the lowest that a cost could be in really any problem?
15.
Well, in this problem it would be 15, but in general the cost would be 0. But yes, you're right. In this problem, it cannot go lower than 15. Okay, I'm going to put 0 just so you can see the axis. But yeah, technically this will not go any lower than 15. And what's the maximum value that the cost could be? Yeah, infinite. We don't know how high the cost is going to be, but we do know we have a horizontal line at 50. If we set our y max to 20, will we see the horizontal line at 50?
No.
No. So we don't want to set the y max to 50 because that's going to put the horizontal line just barely on the edge of the screen. We want to go a little bit more. So what's a little bit more than 50? 60. 70 would work, 80 would work. Those different numbers that would work. Okay, that's all you need to adjust, and now hit graph. There's your horizontal line at 50. And there's the cost of the car increasing as you drive more and more miles. But that's not really helping us right here. What do you think we need to adjust so we can see where these cross? There's one value in the window,
X max.
the X max. And we already know what it is, right? If you're using the graphing calculator to solve a problem, you might not have already done it algebraically, right? Unless you're checking your answer. So we got to set the X max higher. I already know it's 175, but let's just say we were trying numbers. Let's try 200. So there's your horizontal line at 50. Now we can see the cost for the car and where it hits 50. Okay, so now does everybody have a graph that looks something like that? Okay, if you're thinking, well, why don't you just set your X max to like 80,000, right? Then you'll definitely see it. Well, the problem with doing that is that red line now, it basically goes straight up. All right, I can't easily tell where that red line and blue line are crossing anymore. So it's a balance of what's too high or what's too low. Okay, I'm going to go back to 200. 200 showed it very well. All right, now on.
Turned off.
That's okay. There's a calc button on there. Yeah. So on certain calculators, they can figure out where these cross automatically, and all of mine can. If you didn't have a button, what you can do is you press trace, and you move your cursor till you think you're pretty close, and then you read off the number down there. But doing it this way, it's just an estimate. Okay, that looks pretty close to me, and it says 174.2. Well, I know it's not 174.2. That's close, but that's just an estimate. If we want to figure out where it is exactly, we can calculate something on this graph. So the calculate menu, you get to by pressing second, trace. Throughout this year, we will use options 2, 3, 4, and 5. Those are the only ones that we will ever use. And which option in this case is the one that you think we want? Yep, 5. So you can either go down arrow and then hit enter on 5, or you can just press 5. Right? Even if you're not selected, if you press 5, it'll go to 5. Now, when you press option 5, it's going to ask you 3 different questions. First, it says first curve. What that means is pick a point somewhere on the screen that represents one of the lines you want to find the intersection for. Okay, we want the blue one. Doesn't matter where you put your point. You can put it right there. But you have to hit enter. Once you hit enter, it'll come up and say second curve. What it's asking for now is what is the second line that you want to use to find where it crosses another line. So we want to use the red one. Again, you can put your cursor anywhere you want. You're just telling it it's the red one. Once you hit enter the second time, it'll come up and ask you one more question. And that question is guess. So the guess in this particular problem is not important. I'm going to show you when it would be in a minute. But if you want to practice, you can just put the guess kind of close to where you think they cross. Hit enter one more time. And when you do that, you get an answer of 175. Which is exactly what we got there. Okay, so how many people got an intersection 175? Okay. So it asks you a lot of questions that don't really apply in this problem, right? That you don't need. When would the first curve, second curve thing matter? Well, let me draw, just watch me do this. Okay, I'm going to draw one more line like this. And I want to find an intersection point. The calculator can only give you one intersection point at a time. Let's say I want to find where the red and the black cross. Okay. If I have more than two things on the screen, I need to tell the calculator which two I'm using. So I said red and black. Okay, so I'm not going to be using the blue. Okay, so I said that I want to find the intersection between, what did I say, red and black? Was it? Okay. So right now, my cursor's on the blue. I need to tell the calculator the red and the black. And it doesn't matter which order I tell it, but if I press the up or the down arrow, it will switch to one of the other lines. Okay. Now I'm on the black one, and I can tell that two different ways. The font down here just turned black. And if I move my cursor, I can tell it's sliding along the black one. So I'm going to hit enter somewhere on the black. And now I said red and black, it went back to blue. I'm going to keep hitting the up arrow till I get on the red one. So what I did is I'm just picking a point anywhere to tell the calculator, use the red, use the black, ignore the blue. That's where the first curve, second curve is important. The guess still is not important here. In fact, I'll put the guess way over here. And I know they cross way down there, but I'll put it up there and show you what happens. Nothing. Still gave me the right answer, right? Even though the guess was pretty far away. So any question on when the first curve, second curve matters? It's when you have multiple things drawn on the screen. Now, let me do one more. Let's leave the 50. And let's try, in parentheses, x minus 50 squared. Let's see if this does what I want. Maybe. Yeah, it's okay. That's fine. That's a parabola, right? It's a U shape. How many times do the parabola and the blue line cross this time? Yeah, cross twice. And I said that the calculator will give you how many intersection points at a time? Just one. Okay. So when I do second calc intersect, the first curve, second curve thing, that doesn't really matter here. There's only two different pictures on the screen. I want to use the blue. And I can't see my cursor for the second curve because it's up at 2500 and my x value is at 100. If I press the left arrow, you'll see the y coming down, and eventually you'll see it come onto the top of the screen. There it is. Okay, it's right there. So I'm going to pick a point on the red one. Now the guess is important. Wherever you put the guess closer to, it'll give you that intersection point. So if I put it over here, like on that side, and I hit enter, it gives me the one on that side. If I move the guess closer to the other side, it would give me that one. So that's when the guess is important. when you have multiple intersection points between the same curves or lines. Well, lines would never cross more than once, but curves can. That's when you need to use the guess. Okay. And that's pretty similar to how a lot of these second calc features work. Like if I do what's called a minimum, it asks you 3 questions: a left, a right, and a guess. Right? If I do a maximum, it asks me 3 questions: a left, a right, and a guess. Intersect, first curve, second curve, guess. So there's usually 3 questions that it follows up with. All right, so that window that we had right here, okay, that is a good window. When you have a window that shows you everything that's important in your graph, that is called a complete graph. Okay, all you have to do for a complete graph is tell me what did you use for the x-min, the x-max, the y-min, and the y-max. Now, it's kind of a vague definition. It shows everything that's important. Well, what's important? Well, if you're drawing 2 lines, I would say generally the intersection point, if they're not parallel, is important. Okay, that's something you'd want to be able to see. If you're drawing a U shape, generally seeing the bottom of the U shape or the top of it, that's important. And there's not just one answer. Okay, there could be more than one answer that shows what's important. But all you have to do is write down the window. So in the homework, if you see a question that says, find a complete graph, that doesn't mean to draw it on paper. Find a complete graph means just do it on the calculator and tell me what you used for the window. If you see directions that say sketch the graph, that's different. Sketch means to draw it on paper. Okay. Sketch. Take a pencil, pen, and make a sketch. All right, let's try, I guess let's draw this. I think we drew this one yesterday though. Just do it again real quick. So I'm gonna go to y equals, and I'm gonna put in x squared plus 10. And does anybody remember what we use for the window when we're just starting to look at the graph? It's a certain zoom I said to use. Yeah?
It was a Z standard zoom?
Yeah, we just use the standard zoom, and that's going to set your window -10 to 10 and -10 to 10. So after you type in x squared plus 10, do zoom 6. Wait for the yellow circle to stop spinning in the upper right. Is that a complete graph? No, that's an awful graph. You can't see anything at all of what you just drew. What did we have to adjust yesterday to make it so we could see the parabola x squared plus 10? The y max. What would be a number we could try for the y max? 20. All right, let's try 20. Let's hit graph again. Good. I would say that that's a complete graph. You can see that it's a parabola shape. You can see the vertex of it, which is the low point. Yeah, perfect. If you did 30, 40, 50, any of those would have worked. I wouldn't do 50,000 because then it's going to be so zoomed out, the parabola is going to look very flat. Okay. So we're just going to write down what we used for the window. Make that a little smaller. Write that down, and write that down. And I think I just said it though, but what's the name of that shape that we just drew?
Parabola.
Yep, that's a parabola. And the general form of a parabola is y equals ax squared plus bx plus c. The one we drew is a simple parabola. It's just x squared plus 10. But in general, that's the form of a quadratic equation, picture of which is called a parabola. Okay, and we'll do one more graph, and then that'll be it. Probably end a little bit early. Okay, so the last one I want to graph is the square root of x plus 20. So first thing is we have to figure out where the square root is. So go to y equals, clear that old graph. Does anybody know where the square root button is? Yep.
It's a second and then the square button.
Yep, it's second, and then the x squared button, which is the fifth one down on the left. And we're going to type in x plus 20, just like that. Now, we're done. Right? We don't have anything else we need to type in. If you keep typing, it's going to put the numbers under the square root. If you were here and you said, well, I've got something else I need to type, but I don't want it underneath, if you press the right arrow, it'll move you out of the square root. Now you can type in numbers that are not under the square root. Right? I don't want those numbers, so I'm just going to get rid of them and put it as square root of x plus 20. All right, let's try zoom 6 and see how that looks. Now, I will tell you that this graph is not supposed to be a straight line. So based on the screen you can see there, does that look like a good window?
No.
No, because it looks like a straight line. It's supposed to look curved. Let's think a little bit about square roots. What was the name of that biggest category of numbers that I put on the board yesterday that included everything we were studying right now?
Real numbers.
Real numbers. We want this to come out to a real number. Now, there are certain kinds of numbers that if you take the square root of them, they will not come out real. What kind of numbers do we want to avoid where I just circled? Because if you put this kind of number in right there, you're going to get an answer that's imaginary. We don't want that. Yeah, we want to avoid
Negative numbers.
negative numbers. Okay, we have to avoid negative numbers. Right? If you forget, try to take the square root of a negative and watch what it says. It says it's not real. Okay, we don't want to do that right now. So we do not want this to be negative. Then what does it mean we do want it to be?
Positive.
Positive is not quite the opposite of negative. So if we're going to eliminate all the negative numbers, what does that leave us? It leaves us with more than just positives. Yeah?
Leaves us with x values negative 20 and above.
Okay, so yeah, because so what I'm getting at is if you say it's not negative, that means it could be 0 or a positive. Okay, so it includes 0.
Whole numbers?
No, because decimals and fractions are okay. But it's all numbers that are non-negative means 0 and up. If you just say positive, you're leaving out 0. So we have to make sure that this is always, where did I have x plus 20? This has to come out 0 or higher. If you move the 20 to the other side, that tells you what x has to be, which is what was just said. Any number, negative 20 and up. If you plug in negative 21, you're going to have a problem here. Because negative 21 plus 20, that's negative 1. Don't want to take the square root of a negative number. Square root of 0, no problem. Don't take the square root of a negative number. So, knowing that you can put in any number negative 20 or higher, if you go to your window, we're not going far enough to the left. What number do we have to adjust so we go as far left as we need to. We need to adjust the x min. And I would probably do a little past negative 20. Let's do like negative 25. And let's see if you can tell that it's not a straight line and that there's a curve to it. Okay, so like that. Okay, do people see the curve to it now? Yeah. Before, you were zoomed in on a section like that. So yeah, if that's all you're looking at, that looks pretty straight. But when you zoom out enough, you can see that it's a curve. All square root functions look something like that. Okay? A square root function is half of a parabola on its side. That's what a square root function is. If I put this in, negative square root of x plus 20, that would be the other half of the parabola on its side. Okay? That's not what we're drawing. I'm just showing you the other half. Okay. All right, so what did they want to know for this one? Find a complete graph. This is what you'd want to write down for your window. Negative 25 to 10 on the x, negative 10 to 10 on the y. That's it. Any questions on that? Okay. So we're not combining this with 1.3 today. So we just have the page 20. So it's just those problems. And we have a little bit of time left, so I'm going to list out the topics that are going to be on the test. You are going to have a study guide tomorrow anyway, but since this is the last video for the week, I'll put those topics down.